Good morning, everyone. So I'll be your host for today. My name is Tasneem, and let's wait for just 5 minutes for everybody else to join in, and then we can go ahead and start the session today. Okay. Good morning, everyone. So let's begin. Today we are going to have a session on amplifying our science skills, and we have two very excellent speakers with us who are going to facilitate this session. I would like to begin first with introducing Veena ma'am. Veena ma'am, can you unmute yourself? Can you say hi to the audience, Veena ma'am? I'll put you on spotlight right now. Yeah. All right. So we have with Veena ma'am over here with us. She is the principal of National Victor Public Schools in Delhi. And she has 22 years of experience teaching administration and management of school activities. As well, she has a vast experience and expertise in handling a very big team. She also has won a lot of awards. She is also a professional member of the District Coordinator of Noida from Department of Science and Technology from the Government of India. She is also been awarded internationally by BITS, that's BITS Dubai. She's won International Best School Award by Scholar. Asia Today awards also her, and she's also awarded by the Education Minister of Finland. She has successfully completed teaching with technology basics. It's a Microsoft course. And she has filled around 13 patents, to which one has been granted in October. That's excellent, Veena ma'am. Patents. That's excellent. Congratulations on that.
Thank you, Shubha. Thank you.
So she's one of our speakers, and equally we have our next speaker who will be along with Veena ma'am today is Mr. Shubham Chakravarti. Mr. Shubham is a PGT in physics from Ghaziabad. He has over 13 to 14 years of experience in teaching. in high school and physics as well. So, Mr. Shubham, can you please wave to the audiences? You can unmute yourself and wave.
Yeah. Good morning,
Okay, that's
everyone.
great. Yeah. So I'm now going to hand over the session to Mrs. Veena ma'am first. So, Veena ma'am, all yours.
Okay. Good morning, all of you, once again, and thank you, Shubha, for a lovely introduction. You have introduced me. Here, I think so. We have a gathering of, I think so, 180 participants. We can see. So all young, enthused, and eager to learn. The people who have joined us once again, a very good morning and welcome you all. As ma'am has just told you, whenever we go for any workshop or anything when we start, that the word she has told that the patent has been, we have filed 13 patents and then one is being granted. So the question comes, ma'am, what do you do to get all these things? So see this, I will discuss all those things also today. That is, thing is that we work like a children along with them. Shubham also has worked a lot on these many what all patents we are talking. So we just work with the children as a children, and then we give them a wings to their thoughts. Because whenever we talk about any patent, any innovation, anything, any stupid idea, we need that, and the stupid idea can be given by the children. So
Veena ma'am, so sorry to interrupt you, but our participants are not able to hear you clearly, ma'am. Your voice is breaking up.
Just a minute, ma'am. Give me that. I need to switch off the fan. Just hope. Am I clear too now? Am I clear now? Am I
Yes,
audible?
to me, you are much clear. Audiences, you can go ahead and yes, I think it's clear to the audience. Yes, ma'am,
Okay.
you can continue.
Maybe because of the fan. So today in this workshop, once again, let us become a small child and then have any stupid ideas and discuss that and explore. So by the end of this workshop, each one of you should have an idea how to go about that with the stupid idea to an innovation. So let's begin with this, Shubham. Today's that is topic is that the competency what we are going to talk. So before entering into this, I just have a small question from all of you. When we teach about the photosynthesis, the process of the photosynthesis, we simply teach the children that it's carbon dioxide, water in the presence of sunlight, and the chlorophyll. The plants make food and water. Okay. My question is this: that I'm providing you water, I'm providing you carbon dioxide, I'm providing you with the chlorophyll, I'm asking you to stand under the sunlight. Can you make food? Answer quickly in the chat box. Can you make food? One, no, no, no. Third and no. Third one, no. Again, no. Almost, I'm getting no. So my question is this, that when you are teaching this thing that carbon dioxide plus water in the presence of sunlight and the chlorophyll, it can make food. Plants make food. Plants are making food because they have chlorophyll. So I have provided you all those things. Why we are unable to make food? We are very much advanced nowadays. We have a well-established labs and all those. Why are we not able to make food? Hurry up fast, quickly. What is the reason? We are teaching this thing, carbon dioxide, water, sunlight, chlorophyll makes food. And we are only answering, no, we cannot. Though the ingredients are same. Why? Hurry up fast, my dear girls and boys, quick. Absence of light and dark reaction. Yes, heterotrophs. We are not plants. Okay. We are as we are human. But my question, listen to my question carefully. I'm asking you, no soil, no having roots. We teach that plants make food in the presence of carbon dioxide, water, sunlight, and chlorophyll. I am providing you all four ingredients. Plants means the chlorophyll. So why are we not able to make food? This is the thing what we are teaching to the students. Needs chloroplast in the present, don't have stomata, needs some process of to convert the food, but we need to move that machinery of plant, mechanism to prepare good food. You people are hurry, keep trying, you are reaching to the answer. You are very close to the answer. Hurry up. Yes, good soil, trap the sunlight. Manpreet has written we can't trap the sunlight. Exactly this is the answer. This is the answer. Answer says that we are having the sunlight, everything is there, but cannot convert CO2, don't have leaves. Okay, I'm coming to the point now. The thing is this, that when we teach the children, especially the science, we give them these are the rules. We never try that how these rules are getting implemented, and that's called hands-on. So we all are going to do this. Shubham, let's start with that thought-provoking activity what we have planned. Come back. Shubham, unmute yourself.
Yeah.
So
Hi, everyone. So, the first activity that we will be doing here, fine. Obviously, Veena ma'am has planned out quite a few activities. You'll be seeing some videos and all also. Fine. The first activity that we are going to do here is we are going to, like when you are teaching the children about various, processes. Now, I being a physics person, you will find me a little leaning towards the physics part. So, we tend to teach them a lot of things, and we sometimes do hands-on activities, etc. Okay, so I'll be showing you one activity here first, and that activity is essentially how we can make a cloud in a bottle. Fine, and thereafter we will move forward and we'll understand the meaning of competency, and thereafter we will start off with a slurry of activities. There will be 10 activities, one after the other. Fine, which ma'am will be focusing on. She'll be describing it to you. So let me quickly let you know a few things about how we can make a cloud in a bottle. Now, in one of the classes, I believe in class 6 or class 7, we have this chapter on, I think, wind, storms, cyclones, and then also in the earlier classes in the environment studies up to class 5, we deal with clouds and weathers and behaviors. The question is, how do we tell them that what are the ingredients to make cloud? Now, generally, what we say is that, see, what exactly is cloud? We say we have water, fine, water droplets, and they condense on dust particles at higher reaches of the atmosphere, and that forms clouds. The problem is, how are we going to show them in laboratory setting? We can have water, we can have a confined space, we can substitute dust particles. The problem is the sudden fall in temperature. And the sudden fall in temperature, which leads to the precipitation of water vapor, condensation of water vapor into water droplets. That is the point which can be achieved in two different ways in the laboratory setting. The first way is to attach, pressure pump, fine. जिस तरीके का वो, the one that we use to fill air in the vehicles, wheels and all, tires rather. And the second method, which is a much easier method, is the use of bottle like this. Fine. Remember, when you're using a bottle like this, the bottle should be crushable.
Sir, I'm so sorry to interrupt you, but our audiences are not able to hear you. I request you to be a little louder.
No, ma'am, he is very clear. Ask the audience to set their volume, their device volume. He is very clear.
Sure.
Clearly.
So participants, please work on
your dear participants, if some of you are unable to hear me, please check your net connection and all, fine. because from my end, I believe things are pretty fine.
Yes, you are very much clear.
Fine. Okay, so yeah. So what I was saying is that you take a bottle like this. Now remember, take a bottle that is crushable. Fine, that can be crushed. Oh, जो food grade मोटा वाला bottle होता है, please don't take that. Otherwise, you will require the power of a gorilla in your hand. Fine. So you will not be able to crush it. Now, the first thing you require is a confined space. The second thing that you require is water. Can you see water in this? A little bit of water. The third thing and the most essential thing is to move it like this so that the entire confined atmosphere inside the bottle, fine, that gets moisturized. Fine, it should get saturated with water. Then we require what we call as dust particles. Some particles where the water vapor will condense. Now, we do not have that much of dust particle in here. So we will substitute that with smoke. Fine. So be a little careful about this part. Fine. So I'll just, oops. Okay.
Shubham, adjust your camera.
Oh yeah. I'm sorry.
Yes.
Yeah. Can you see this? Fine. Be a little careful about this.
It's clear.
Okay. So we've got smoke. We've got water. Now the next thing to do is remove the water. For God's sake, remove it. The best way to remove it is, if the water is clean, drink it. Now insert inside and let a little bit of smoke stay inside. Once the smoke has gone inside, quickly close the lid. Okay, now comes the difficult part. How to decrease the temperature inside this? Fine. This is basically adiabatic compression and expansion. Can you see this has got fogged out? Oh, I think I will serve as a good background. Now, let me just close it again and let's do it quickly again. Can you see this has got fogged out again? If you're thinking this is the same smoke, then you're wrong. This amount of smoke is very, very small. Now see, it's almost clear. And you can see it is fogged up again. Fine. This third component, which is basically decreasing the temperature inside the confined, that is a very important aspect. The temperature inside has to drop dramatically and very, very fast. This happens when I compress this thing to, I use all my might, I compress it and I suddenly release it. See, it became fogged out again. I compress it and I suddenly release it. The moment I suddenly release it, it will become wild because the temperature inside drops. And whatever water vapor was there, it immediately condenses on the smoke particles, creating a small cloud inside this bottle. I hope this small activity, will be helpful for you when you start explaining nature, when you start explaining weather patterns, etc. Fine. And there is no confine, there is no limitation as to which class you can do it with. You can do it in the middle school also, class 6 to 8. There is a couple of chapters in that, and you can do it in the primary level also. And trust me, you do not require any big thing. You don't require any costly instruments, etc. Just a bottle of water. घर में पड़े रहते हैं ऐसे bottles. Just pick up one bottle, and I used the incense stick. You can use a paper, just burn it and drop it, and it will do the trick. So this was the first activity that I've shown you. Now I'll move ahead and I'll hand it over to Veena ma'am again. Fine. Veena ma'am? Yeah. So I'm handing it back to you.
Let me once again ask Shubham.
Yes, ma'am.
They all are ready to first let them experience that. All of you must be sitting with the paper. Audience, Were you told to sit with the paper?
Do you have A4 size sheets with you?
Paper or a newspaper
Yeah,
or
yeah,
anything
yeah,
with
exactly.
you? So yes. Okay, fine. So now do one thing. We are going to ask you, all of you switch on the videos. Your videos you must keep on. And here is your question. You are going to get only and only 45 seconds to do this activity. Now,
No, the activity would be, ma'am, should I explain or would you?
Yeah. Leave them the question.
Yeah. See, the activity is pretty simple. You've got the A4 size sheets, fine. And with this A4 size sheet, what you have to do is you have to start tearing it. Remember, isko pura ka pura phad kar alag nahi karna hai. Fine. If you have a sheet like this.
No, Shubham, let them. Don't tell that. You have a sheet. Your question is that you need to create a tail as long as possible, and the size, the width of the tail needs not be more than 1 inch. Means that you have to create a tail from this paper, a width of 1 inch. This width need to be almost 1 inch, almost, not completely, almost 1 inch, and the longest tail will be awarded. Okay, I think so. Your question is clear. You need to create a tail.
I can see Akal Academy Baru teachers have already started doing it.
Okay, and your time started now. Start it.
Okay. Yeah.
Hurry up fast.
I can see only one video and I can see they're doing well.
You can share.
Okay. Yes, Dr. Anju Gupta is also doing it.
Very good, Anju ma'am. You are going in the right way. Hurry up fast.
Yeah. That's the correct way to do it.
Yeah. Alka. Yes. Akal Academy. The teachers are doing very nicely. Perfect.
Shashi ma'am is also into it.
Yes. Shashi ma'am is also going in the right way. Prasanna is also going in the right way. Hurry up fast. Amandeep is also trying. Yes. Yes, very nice. Exactly. Kusuma Kumari is also trying to do. Tapshri Banerjee, you are going in the right way. Okay, Sarabjit, yes, hurry up fast. Very good, excellent. Before we finish, let us see that who is having the longest one. I can see Ramakrishna is also doing. Yes. Oh my God, Ramakrishna, wonderful, excellent.
Awesome.
Good. Hurry up fast.
Okay, Aarti ma'am is also doing it. She's also got a pretty long one actually.
Yes. Aarti is going in a little different way. Let us see
that.
Yeah,
She's
what exactly is this that? Amandeep is also taking it a long way. Yes, Neha Bhatti is also gone. Okay, this is
Neha ma'am. Yeah, that's pretty long.
Shravan is doing in some different way. I think so. It will be nice if after this activity, all of you just rather than having a device name, if we have the personal name of the camp.
Yeah, because some of the
it will
teachers.
be nice.
Yeah, the personal name is not showing, so it becomes difficult to take the names actually.
Okay. So don't feel bad that we are not calling you by name. One is there, 1 plus 70, that is very well organized. Now, actually, to get this.
Look at Akal Academy teachers. They've made a pretty long one.
Long one. Nahi, Rupinder is also going. Keep on making.
Okay.
Actually, who is it? Divya also. Divya, very good, excellent. Can you? Yes, very good. What was the size of the paper, Divya? Must we have that? Aarti is also
Dr.
ready.
Anju ma'am has also done it pretty well.
Very well.
It's pretty long actually.
Shashi ma'am is also good. Okay, Tapsi is very good. Done. Who is that? Gurjeet is done. Wait, let us see. Akal Academy.
Tapsi ma'am has made it pretty long.
Yes. Anju ma'am is also done. Good job. Okay, so Tapshri, your things are very good. The last one is okay. Amandeep is very nice, Amandeep. Okay, Shashi ma'am, you are very good, excellent. Rajni again has done an excellent job. Okay,
Ma'am, look,
yeah.
yeah, look at Dr. Anju
I'm
ma'am's.
coming.
Yeah,
I'm coming to
yeah.
Anju.
Actually, we have quite a few participants. It becomes very difficult to search through every one of them.
Ramakrishna, may I see the length of your
Yeah, Anju ma'am.
your
Yeah, that's pretty
tail?
long.
I'm so sorry. Everyone has now. Very good, excellent. It's quite big. Wow, 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 wow. Okay, done. So now my question is this: that okay, very good, well done. Give a way round, a way. Well done, excellent. A round of applause for you all. Deserve. Pat your back. Now my question is this: that what did you learn from this? What did you learn from this? Come on, hurry up fast. What is the learning outcome of this activity?
Yeah, apart from the fun that we had, the question is, what did we learn from it?
What is the learning outcome? Creativity is the first answer. Yes. Only the one answer, creativity, that how to produce more from less.
Innovativeness, yes.
Fun activity.
No doubt,
Brainstorming.
brainstorming, yes.
Uh,
Everyone's involvement, yes.
Learning by
Group working
doing.
is very important.
Fine
Collaborative
motor.
effort.
Mr. Ramakrishna, excellent. You have got it. Motor skill. Yes. Competent speed, hand and brain. Proceeding from this connection. Productivity. Learn by activity. Concentration. Reducing small. Was there any concept? Did you find any concept behind this activity? Any logic, any law of science, or any rule of science, or anything did you find behind this? Cognitive and creative skills?
Best of the best, yes.
Yes, that can be. And just my question is this: did you find anything, any concept behind this?
Yes, Ranjana Sharma ma'am, that's correct. That's one way to look at it.
Yes. So, any scientific law? Did you find circular motion? How come it's a circular motion? Sashilamba ma'am is telling circular motion. Padma is telling force. Carbon chain. Ramakrishna is telling that carbon chain. Yes. Any scientific concept? What do you think that you can use this activity to explain it? Energy. Learning by doing, force, matter and its building blocks, DNA strand. We use circular motion to create this spiral. That's what I was coming. That is a very different activity, but this is something different. Energy. So you yourself has, when I have asked you what is the learning outcome, you yourself has told lots many things. So, and then hardly we were bothered about the concept what we had looked behind this. So I'm coming, Shubham, may I get the first slide?
Yes, ma'am.
Okay, so coming to that is that what do you mean by competency is what exactly the meaning of competency means. Is there anyone who can answer that? What do you mean by the competency? In a short, let me explain and then come back to that activity portion. Change in the perspective of individual. Yes. In a simple word, if I say that, next slide, Shubham. If I say that a person is enough competent to handle the gathering of 100 people, it means that the person has skills set or ability needed to handle a group of 100%. Let's move next. So when you have done this activity, a paper activity, see that on the screen you will find almost all the skills what you had discussed while I have asked you what is the learning outcome of this activity. So learning outcome, the knowledge, communication, back. So communication, people management, leadership, all those things you have seen. So as Shubham, next slide, the purpose is that what do you mean by competency based learning? So in the competency based learning, we need to sharp 3 skills, that is the skills, knowledge and ability. So yes, you are very much right. So while you were doing this activity, despite of having any scientific logic behind this, you have developed these three things. That is skill, knowledge, and ability. My dear participants, today you all know how to do that. You all are having a lot of exposure of hands-on activity. But the thing is this, that when we talk about the competency-based science learning, it is not only to develop the skills, it's not only to develop the knowledge, it's not only to develop the abilities, it's not only to develop the communication skills, it's not only to develop the leadership skills, it's a combination of all. And being a science teacher now, it's a demand. That's what we will discuss later on. So what is the 21st century competency based parameters, that also we are going to. So Shubham sir, so this is how, if we have all these three things, the skills, ability and knowledge, they all are connected, and these three things makes a person competent enough. And
Yeah,
this is the demand. Yes, Shubham?
Yeah, just having the skill or the knowledge or the ability by itself will not define you as a competent enough teacher. Or it does not mean that you have been able to develop the competency in the student itself. You have to develop all the three together. And
See, Shubham, I'll just give you an example, audience here. While I was, and there is every year, if in a Rashtrapati Bhavan, you will in the President House, they put the exhibition of innovative innovations, and those innovations they talk about the people. They bring the people from all around the India to show their innovation. There I have gone to one counter. In the counter I found that they have kept the wheat. I asked what is the specialty of this. The person has told me, ma'am, this wheat is different from a normal wheat. How? Then he has shown me that chapati dough was there. This is the ordinary wheat, this is my wheat. You can feel, being a lady, you can feel the difference. I said, okay, it's fine, maybe like that. Then he has told me, taste the chapati. I found that chapati was different, that normal chapati and this. I said, something must be added into this. How should I think about it? But when I have seen the structure of a wheat, normal to this one, I could find, yes, it is different. Then I asked him, how come you have done this? So he has told me, ma'am, simply we have found 2-3 plants in the field, and then we have collected, they were different, and with the seeds we have innovated or this. I asked, how come you have found? Is it in hybrid? The person was not known. He was not known about any term, scientific term which we talk about. Then I asked, yes, Bache?
I'm sorry, but ma'am, your voice is breaking up a little.
Little, okay. So I'm coming a little closer.
Yeah,
so
you
now
just come a little closer.
Okay. So the thing is that just a minute, Shubham. I need to open that. Sometimes connection problem, no, so I have opened that the door of the this one. So what the person has told me, he used to go for a morning walk, and when the early sun rays falls on the in the field, he could find these 3-4 plants differently. So I just wanted to tell him that he was having the skill, but he was not having the knowledge, he was not having the ability. So that's the question arises, that the combination of these three things, the skill, knowledge, and ability, makes a person competent. Yes, Shubham, now you can.
Okay, ma'am. Now I'm again going back to you only. We are now heading towards that video, fine, in which we'll be showing 10 different experiments, fine, and ma'am will be discussing the experiments with you. Okay, so ma'am, I'm starting off the video now.
So let the audience gear up, one after another, back to back. You are going to, yes.
So I'm starting the video now.
Yes.
Can you all hear the sound of the video? Sorry. Just a minute. I'll Okay, it's okay. If you're not able to hear the sound of the video, that's actually good.
No, sound is very clear.
Fine. Okay.
Stop, Shubham. Stop.
Yeah,
Okay.
yeah. I've stopped it.
Stop this. Now, the first is that what is the learning outcome of this activity? What is the aim and objective of this activity? The color chromatography is written there. What is the aim and objective? Hurry up fast. I'm waiting. Chromatography is there. But sir, Ramakrishna sir, I'm asking what is the aim and objective of this activity? Hurry up fast. Come on, girls, boys. To separate the color from the black dye, someone has written separation of material, separate the color from the mixture, how to show the separation of dye. Poonamjeet Kaur, I'm very happy that you know the meaning of what is the aim and objective. Separation, traveling colors from the material to solve. See, separate the color of dye, separation of dye, solubility, separation of this, to know the component of a dye. Yes, exactly. This is also an aim and objective, to know the separation of color from dye. Now people, yes, Ramakrishna, now I'm happy that you know, you got my point and you caught, and that is the learning outcome, separation of colors on the basis of that. See, to separate the color of dye. Now coming back to the point, yes, all of you, excellent attempt. What is the aim and objective of this activity? Once I have asked you, when I have shown you, it must have come in your mind that what man is showing, it's called a chromatography. But when I have asked you, what is the aim and objective? I got lots many things. So the question is this, that now what is our learning objective today is that you see that one activity is having lots many concepts. Okay, and then through one activity, you can teach lot many things. So here, just now, you all have explored that. We can teach this, we can teach that, the separation, we can see solubility in solvent, lots many things you yourself has explained. So when we talk about that is when we are explaining this activity in class nursery, then we can tell them the concept of the colorless in color. The water is colorless and the color. When we go gradually, you will find that till class 12th, you can use this activity. Only that aim and objective will change as per the class. Yes, Shubham. Next. Be ready. Next also, I'm going to ask you an aim and objective. Walking water.
Yeah, I've stopped it, ma'am.
Yes. Now, let me know that I have not, this time I have not given any name. Earlier you were having that is chromatography. Now, what is the aim and objective of this activity? Some of you have caught me how to write that, how to know about that aim and objective of that. Movement of the solvent with the color, capillary action, exactly, transferring of color, exactly, spread of color, okay, aim to show the particles, the matter through the medium. Yes, very good, excellent. Diffusion, excellent. Color chromatography, excellent. Movement of solvent through a medium. Absorption, very good. A very minute point. Capillary action, movement of particles, absorption. Very rightly, many of you have taken that Adhesive force between the water and a paper. Very good. What a answer. Kavita, I'm very happy. Excellent answer. Two different colors, absorption, osmosis. Can you explain osmosis with this? Very good. Otherwise, now I'm coming back to that. I got that absorption of water. See, again, I'm coming back to that. It is to be said that if you are showing this activity to a nursery class child, you can show that, or a class 1 child, that water is walking from one class to another class. Okay. And gradually you can take it to the osmosis. So the purpose, what 10 activities I'm going to show you are the activities which you can use from class 1 or class nursery to class 12. Shubham, am I audible? Okay, water appears defy gravity, but isn't it due to capillary action? Capillary action is, yes, can be shown through this, but for that is, you can say that is, sunlight is also required. The transpiration need to be added with this. Okay, Shubham, please move for next. Let me, Shubham, don't.
I stopped it, ma'am.
All
Yes.
of you know now. Let me know that aim and objective. Hurry up fast. Surface tension. Shubham sir will explain you. Hurry up fast. Cohesion. Yes. Air exert pressure. Next. Hurry up quickly. Show the atmospheric pressure to air exert pressure. Gravitation and atmospheric force acting downwards. No. Pressure of air in upwards direction. Atmospheric pressure act on a cardboard. Force of attraction, air pressure. Shubham sir, please.
Yeah, actually this particular experiment that is demonstration that you're looking up here, initially it used to be said that it shows atmospheric pressure is pushing the cardboard from the downward direction, and hence the water is not falling. But this is not entirely correct. Yes, atmospheric pressure is definitely one reason, but there is another point to it. And this point came to light when people started watching this thing very carefully, very closely. There is an aspect of surface tension and cohesion also of addition also at work here. Fine. The exact mechanism is not fully understood, but it is not just atmospheric pressure, but it is also atmospheric pressure plus surface tension and addition working together to keep this water thing, this cardboard in place. In fact, you can actually perform this experiment with 1/4 or even half the glass full of water, and yet this cardboard is not going to fall down. Fine. So you can actually repeat this experiment and see for yourself. So the one possible, and in fact the probable answer to this thing that you see here is that the cardboard is being pushed upwards due to atmospheric pressure, plus there is surface tension and adhesive forces at work to keep the entire cardboard at hold.
So I think so. Hope the audience, you are clear. Till now we were having the misconcept of that atmospheric pressure only, but this experiment is a combination of 3 concepts, which seems to be very easy for the primary classes, but actually it is not. For primary, you can give them just simple an idea of air pressure.
For the lower classes, you can only talk about atmospheric pressure, but as you move in the higher classes towards class 11th,
yes,
fine, then you will have to also explain that it is not just atmospheric pressure at work, but also surface tension and adhesive forces at work together.
So all 3.
There is another experiment ahead of it that we'll be discussing in detail.
Yeah. Yes, Shubham.
Okay, I'm moving ahead with the.
Okay. How much? Yeah. So now quickly aim and objective of this activity. Immiscibility in nature. Yes. Come beyond that. Immiscible nature. It's something beyond this also is there. Difference, yes. Density of the liquid, yes.
Exactly.
So when we talk about in the lower classes, yes, immiscible nature is very much right. But the question arises that Taruna is very nicely writing that. Now, when the question arises that how to make the child, we talk a lot about the densities, okay? But when the question comes that we always tell assume this, you look, go at home and see this. But this experiment tells the child about the different density of the liquid. So the concept of density by not only by touching, by seeing, by to feel it, this is a very good activity. Very nicely, you all have got the point very nicely. Okay, let's move on next. Yes. So now reflection. Yes. Think from the primary lateral inversion, refraction, mirror reflection, refraction of light, lateral inversion, lens. Yes.
Yeah, the lens effect.
Lens
Yes.
is the main concept.
It's basically the convex lens effect that is taking place here, due to which
Yes.
we are having a lateral inversion.
Shubham sir, please explain because I'm getting a lot of the people are having a confusion about that. So please
See,
just
basically,
explain
it is not about reflection of light,
Yes.
but as somebody pointed out, it is refraction of light. So when you're going to introduce refraction of light, this will really help. And along with refraction, when you're going to introduce about the lens effect, especially the convex lens, fine, you will actually find this particular activity pretty helpful there, because the light from the horizontal axis, fine, it is getting refracted, okay, and when it reaches you, it has already inverted itself in the horizontal direction. That is why you are getting this optically, what do you call it, horizontally
Illusion.
inverted, yeah, laterally, yeah, this lateral inversion that is happening.
Lateral inversion. So water act as a lens. Shubham sir, just stop here. Now my question is this, that my dear audience, I just want to know that you can ask the question from the children here as am I asking, where is it applicable in the life, normal life? How can you use it? Where it can be used in a normal life? That is called an application part. Ambulance, where it can be applicable for a normal life, and keep yourself in a place of a student, एक छोटे बच्चे की जगह, if how come it can be used? Mirrors, cars, to magnify exactly this thing. The water also works like a magnifying glass for a chota sa bacha, for a small child. It's a magic for him or her. Exactly, this can be, yes, it's an answer that's to magnify. This is an application for a small child. Okay. Yes, sir, you can.
Sorry. Very sorry. Just a minute. Yeah.
Okay. Shubham, little bit you need to.
Yeah, remain back a little.
Remain.
I mistimed it.
Mhm.
Yeah, there it is.
Okay. So what exactly is that? Already it is given polarity of water. But what is the aim and objective of this? Once again, hurry up fast, quickly. Shubham sir, electrostatic force charging the object by friction
Yes,
to show the
actually, yeah, there are many things that can be done shown with this particular demonstration.
That's
The
what
first
I.
one is charging by rubbing. So this balloon has been charged up by rubbing it with that fur thing that was shown before, and now we can see the stream of water is moving towards this balloon. Now that is what is happening is that the balloon has static electricity. Now you always obviously know this. The balloon has static electricity, fine, and that is attracting the water. The water we know is a polar dielectric. Fine, it already is polar. It already has an inbuilt polarity in it, and because of that, it is getting attracted towards this balloon, which is already charged up. So there are two things that you can demonstrate. Ma'am, over to you.
Okay. So you were very right. That is water molecule attracts other molecules. You all have reached to. Shubham, come back, please.
Yeah.
So quickly we are moving that as sir has told, but only the thing is this: the polarity word is a polarity of water is very important, which you need to explain to the children because they get it is this is the concept which is till the class 12th they do all those things, but the concept is not clear if it is not done properly in the childhood level. Okay, so, sir, please.
Now, I will recommend please watch this carefully because you have already done a similar experiment in school when you were in school, and you must have done it in as a demonstration to show certain things to the students also. And we are going to do a little bit of a myth busting here. Here comes my question. Why did the water enter this glass? What is the possible reason for that? Yeah, please write down the answers. Why did water get inside? Air pressure, fine. Air exerts pressure, surface tension due to pressure. Okay. Temperature, yes, Divya ma'am. Absence of air, fine. Pressure, oxygen was used up. Okay. Okay, fine. Now see, yeah, as I can see, many of us have this concept, or rather, I should say, a little bit of a misconception here. In our school days, also, we used to be told, how to show that air has exactly. So we were told that air has got about 20-21% of oxygen. How to show it, and this experiment used to be done. This is not about that oxygen is being used up and hence water is getting inside. No, that's not the correct explanation for it. The reason being that as oxygen is being used up, fine, we also have carbon dioxide being released, fine, and we have a certain amount of water vapor also inside. Plus, there is a lot of heat, fine, when the thing was burning. So what actually happens is, as this cinder inside, which is burning, as it exhausts itself, fine, as it gets extinguished, there is a sudden loss of temperature inside, fine. The temperature starts falling, plus the water vapor inside it start condensing, because of which there is a partial pressure that gets created, and the water is sucked in. Now, if you do this experiment with two of these matchsticks or whatever it was inside, fine. If you do with two of them, the water will rise in further. You use three of them, the water will rise to almost 50% inside the glass, which will clearly demonstrate that this experiment does not talk about that there is 20 or 21% oxygen in air. No, this experiment is not for that. This experiment just talks about the ideal gas law, fine. There is a temperature and pressure involved, fine, and within a constrained volume. You raise the temperature, fine, and you raise the pressure, and when the fall down suddenly, you will have a difference in pressure which will lead the water inside. So this is not about oxygen, 20% oxygen in air. Okay, so many of us, even in our school days, we have studied this thing. Our teachers used to teach us the same thing, and till about like 6-7 years back, I used to also teach the same thing to my students. But then I realized through a failed experiment that that is not the case. Fine. And now we understand that if you use the number of candles, now we used to do the experiment with candles. Fine. If you use, instead of 1, 2 candles or 3 candles, the amount of water inside will keep on steadily going up. Okay, so please do not ever do this experiment again in front of students to show them that air has 20% oxygen. This experiment is not for that particular purpose. So this is a kind of a myth that we have, and some of the books still carry this particular experiment under the wrong heading. Fine. Okay, over to you, ma'am. Hello. Okay, fine. Then I'll move forward.
Shubham, you can stop. I was actually muted. Now I'm going to unmute this.
Okay, fine, ma'am.
It's a very hard. You will see this. You must have seen this activity in class 6. Book is given, and there also the concept is explained. This that it is to be said that air is made up with these many gases, and oxygen is used in the burning. So the place is left, and which is occupied by the.
Yeah, that is not
oxygen.
true, actually. That is not.
But if while the combustion is taking place, then the conversion is taking place also. So oxygen is converting into the during the combustion in the carbon gas.
Exactly.
So
oxygen has been taken
in,
and the carbon dioxide has been released.
Produced. So it is a very simple thing that the place has been taken by the carbon dioxide. How come the vacuum has been created, and how come that the water level has very simple concept? Hot air goes up. That's all. When you were burning the candle, the air got, the air has become hot, and the hot air goes up. In that way, you can explain to the children. Very simple. Okay, so now move on next. Yes, Shubham sir.
Yeah, stop it, ma'am.
Yes, hurry up fast, quickly. What electrolysis is written there? Shubham sir, can you explain decomposition through electrolysis? Yes. Shubham sir, what else can be explained in this?
Well, explain.
We are running short of time.
Yeah. Sorry. See, we can explain a couple of things. Obviously, we can show them electrolysis and how it works, and we don't require any dangerous equipment for this. For this, they have shown a power supply, but you can also do it with a 9-volt battery. Find the blue ones, the high watt 9-volt batteries that are there. You can actually start with that. Obviously, the process will be a little slow, and this can also be done, without using salt. Now they poured salt in it. If you don't use salt, you'll see that the reaction runs very, very slowly. And as you start pouring in salt and dissolving it, the reaction just speeds up a lot. Fine. That also shows you, how a water can be proven to be, dissolving of, external solutes like salt. They can be shown to be, make water conducting. So, there are a couple of things that you can actually show using this particular experiment. And again, it is not confined to any one particular group of classes or any one particular group of students. It can be done at any other level. Fine, you can actually start off with showing that water is a poor conductor. Then just add salt to it, and you show that water added with salt becomes a pretty good conductor of electricity. Then you can show them about electrolysis. And if you can Like in this particular case, the test tubes have been used, and the accompanying the released gases are being captured. So you can also show them what gases have been captured in there. Fine. So there's a lot of things that can be done with one simple experiment like this.
Okay, sir, we can move ahead.
Now, in this particular experiment or activity, you can actually show them that, see, in diffusion, fine, whether the diffusion is happening in air or whether it's happening in water, fine. The higher the energy of the molecules, the faster the diffusion will take place. On your right hand side, this red dye water, and that water is warm, whereas on the left hand side, it's the cooled one. So as you can see, the red dye is getting diffused pretty fast, whereas the blue one is actually very slow. And that is a simple explanation. The simple explanation is because the water is warm, which means the molecules have a lot more kinetic energy in them than the cold water, and that is driving the diffusion so fast. So that becomes a pretty simple explanation to this particular demonstration that you can show regarding diffusion of molecules.
Yes, sir. You are very rightly told that. Yes, sir. Very rightly, Shubham, sir. You have told that we, for the smaller level, when we talk about the every matter is made up with a molecule, and molecule is not seen. So the child is everything is imagined by the child. So to show that brown is movement in a color molecule, yes. So that to make the child imagine that the every object on this earth is made up with a molecule, and molecules are having a movement, and molecules are so intermolecular space, the moment, the setting of the molecules, when all those concepts we introduce in the lower level classes, then also this activity is very useful till you teach the concept of Brown's moment or the relation between the kinetic energy and all those. So till higher classes. Yes, sir, you can move ahead. Objective of this activity, it is not an elephant toothpaste. Expansion of matter. Hurry up fast, quickly. There is a concept of even biology, chemistry, physics is a combination of all three. Come on. Characteristics of chemical reaction. Beyond that, hurry up fast. Chemical reaction. Oxidation reaction, it's not exactly. Plasmolysis is not exactly. Shubham sir?
Actually, this is a very good activity to describe rapid oxidation reaction.
Yes.
And the hydrogen peroxide and the yeast water combination, when that leads to a very rapid release of carbon dioxide, which is actually pushing the entire matter outside in the form of a foam, which you can see here as an elephant toothpaste. So this is a very good in the primary classes, expansion of matter is a good idea. Fine. Whereas when you actually start with chemistry and when you go into oxidation reduction reactions and all, to show them how hydrogen peroxide is such a great oxidation agent, fine, you can actually show it to them. Fine. So this is a very good example for the oxidation reaction, a rapid oxidation reaction, rather, I should say.
So when we talk about the catalyst, what is the catalyst which add that the speed in the reactions? This is another example for that. When you teach in the class 10 or 9, when you come all those things point. So for the primary to class, so all together we have done this 10 activities, which I felt that can be started from the class nursery and can lead to class 12 to develop a concept. Okay, sir.
Okay, I'll be showing an activity now. Fine. And as I show you the activity, there is a question in front of you. You can see this. You all have heard about the International Space Station, which is going around the Earth at a height of about 400 kilometers. You must have seen that the astronauts are always floating. Fine. The question is, why are they floating? Why can't they walk like us in the International Space Station? Why are they continuously floating in there? What is a possible reason for that? Yes, this is the answer that I generally get. That's the absence of gravity. No gravity. Yes, no gravity. No gravity. No gravity. No medium. Okay, absence of gravity. Gravity is 1/8 of Earth. No atmosphere. No atmosphere along with gravity. No gravity. Pressure. Gravity nahi hai. No gravity. No medium. Okay, fine. Okay. I got it. Fine. Well, the actual answer. Let me just walk you through. Okay, let's walk through this thing. The gravity, when we say gravity, we're actually talking about the acceleration due to gravity. Fine. On the surface of Earth is approximately 9.8 meters per second square. Oh, I'm sorry. Just a minute. Yeah. So on the surface of Earth, the gravitational force or the acceleration that is on us is about 9.8 meters per second square. At a height of 400 kilometers, if you just do the calculation, G equals to gm upon r plus h the whole square. If you do this calculation, you will find that the acceleration due to gravity in the International Space Station is approximately 8.6 meter per second square. Has barely 12% less than that on the surface of Earth. Then why are they floating? On Moon, it is 1.6, 1/6 of that of Earth, and yet Neil Armstrong, Edwin Aldrin, and other astronauts, they were actually able to walk. But here they're not able to. The reason is not that there is no gravity. Very much gravity is there. In fact, gravity is one force that extends all the way to infinity. Fine. So gravity is very much there. What is happening here is they are in a constant free fall. They are freely falling. And you must have studied that under free fall, you become weightless. Have you ever sat in a Ferris wheel? वो जो होता है ना ऐसा बड़ा वाला giant wheel ऊपर से नीचे ऐसे घूमता है vertically. If you sit on it, when it comes down, you must have felt कि बहुत अजीब सा feel करने लगते हैं, है ना? That is because you are going in a kind of a free fall, because of which there is a pressure difference happening inside your body, which is sensed by your brain, and hence it creates the anxiety inside you. So the answer is not that there is no gravity. There is enough gravity. There is more gravity at International Space Station than there is on Moon. Fine. The answer is not that there is no gravity. There is enough gravity. The answer is also not that they're in vacuum. No. Inside the space station, there is atmosphere. Otherwise, the astronauts will die. What is happening is they are in a constant state of free fall. They're constantly falling towards the center of the Earth. And that is where they are in a free fall state, which leads to weightlessness. And weightlessness leads to what we call as a floating experience here. Fine. In fact, one of the better things is all of you who have taken a flight, and if your flight has got caught in a turbulence, trust me, mera bahut bar phasa hai, and I dread it. Fine. When your flight gets caught in a turbulence, you are going to experience this. इसीलिए आपसे कहा जाता है सीट बेल्ट लगा के रखिए, कार में ही नहीं, फ्लाइट में भी. The moment the flight goes down suddenly, you are going to experience no gravity, zero gravity, not no gravity. You are experiencing a weightless condition, because of which you'll float up and you might hit anywhere. Fine. So the gravitation is less by only 12%. Fine. It is not enough to make you float. What is actually happening is you are in a weightless situation because you're constantly falling towards the center of Earth. Now, you might ask that why, if you are falling towards the center of Earth, why don't we hit the Earth? Because you have a horizontal speed also. Approximately 28,000 kilometers per hour ka horizontal speed. And because of this horizontal speed, if this is the Earth and you are kind of like, moving like this, you're constantly falling towards the Earth, but the curvature of the Earth is moving away from you, because of which you keep on going around it without actually touching the surface. Fine. So this is the actual reason. It is not that there is no gravity or less gravity. No, the gravitation is not less enough for you to float. Moon का gravity इससे भी 70% कम है, लेकिन वहां पर भी the astronauts were able to walk and jump around. They were not floating. Okay. Now, in the meantime, I'll show you a video. Actually, I'll be demonstrating something. And this is specifically for class 10 and class 12 students. Fine. This is an aluminum plate. And this is a super powerful magnet. We call it a neodymium ferrite magnet. या आपके बार मैग्नेट से एक्सपेरिमेंट जो आपके लेबोरेटरी में बार मैग्नेट होता है वो इससे एक्सपेरिमेंट नहीं होने वाला. You require this magnet. This is called a neodymium ferrite magnet. And just to show you, doesn't get attracted because this is aluminium. But something weird will happen. I hope you can see the plate, all of you. Fine.
Yes,
now I'm not going to touch it. Fine, I will not touch it. मैं सिर्फ इसके ऊपर से इसको I'll just rotate it from the top of it. And you see what is happening? It starts rotating. If I rotate it in the other direction, it will first break and then it will start rotating in the opposite direction. I have not touched it. Trust me on that. I am not touching it. My question is, what is happening? Yes, it is magnetic effect, but what kind of a magnetic effect? It is a magnetic effect, yes. But what kind? And as again stated, it is specifically for class 10th and 12th students. There is another experiment that you can do. I am kind of a little short of time, plus I don't have the proper instrument right now. Yes. Repulsive magnetic field. Yes, Gagandev, you are very close to it. But remember, it's aluminium. See, what is happening is, as I take this super powerful magnet, fine, and I rotate it near it, fine, the moment I start rotating it, the magnetic flux changes very rapidly. Yes, paramagnetism is one possibility, but that's not actually here happening. What is happening here is Faraday's third law, or what we call as Lenz's law. Fine. The magnetic field, this magnetic field is rapidly changing around this, because of which current is set up inside this, a current loop, which we famously call as eddy currents. And that sets up a magnetic field which tries to repel this. Lenz's law, the creation of current in this will always try to repel the magnetic field or the cause of its own creation. Kaise? By opposing the relative motion between the plate and this, and to, yes, induced EMF. Yes, that's the correct answer. It is induced EMF through electromagnetic induction. Fine. And this induced EMF is leading to a repulsion, because of which the what you call this thing, relative motion is repelled and the structure starts moving along with this. This is the very basic idea behind the use of what we call as regenerative braking या electromagnetic braking. बहुत से रेलवेज में, यहाँ तक कि दिल्ली मेट्रो में भी in some of these metro coaches, regenerative braking is used. One of the ways of using regenerative braking is by the use of electromagnetic field. Fine. Yes, Ramandeep ji, Aarti ma'am, yes, Gagandeep, you all are correct. Okay, fine. So I hope you have understood why this International Space Station thing is happening. Fine. Why people are floating also. So now I'll just move ahead.
Another 15 minutes. So we need to take the feedback and running out tomorrow. Okay.
Okay, Veena ma'am, it's over to you now.
Yeah. Yeah, Shubham sir, I just would like to request you to show that laser activity first, because we are having very less time in our hands.
Okay, okay.
So
Fine.
then we will come to that.
Okay, there's another activity I would like to show you. Fine. And this one can be done in absolutely any class. Now, when we tell students that light goes in a straight line, what is the experiment we do generally? 3 कार्डबोर्ड लगा दिया, छेद कर दिया, सामने एक कैंडल लगा दिया, इधर से देख लिया, हाँ जी लाइट स्ट्रेट लाइन में जा रहा है. या फिर we take a pipe, सीधा देखा, दिखता है, टेढ़ा कर दिया, नहीं दिखता है. Fine. When we teach students about ray diagrams in class 8, in class 10, fine, we show them using lenses and all those things. And the students, they have to actually imagine it. They are imagining it. Fine, they are unable to visualize it. The question is, how can we do that here? So I call it a smoke box experiment. You'll require a little bit of things, like for example, a cardboard. I'm using a small one because it's a small place around here. So you need a cardboard, and you need agarbatti also. Okay, you need to create smoke. And the next step is to again light up the incense stick. This is
Shubham sir's lens screen.
Yeah, I'll do that, ma'am. I'll bring it in there. Yeah. Okay, fine. Okay, so there is some incense sticks here. Fine. And light up could be. So I'll just keep it there. Fine. And you have to create as much smoke in there as possible. Now, the next thing is you will also require a laser pointer. Fine. You'll require a laser pointer. Now, I'll just, okay. You all can see it, I believe?
Yes,
okay?
you can see
yeah.
it.
Okay. So I'll just hold it like this. Okay. And can you see the ray of light here?
Yes, it can be seen.
Can you see the ray of light? Fine. You can actually see there is a little less smoke here. With a lot of smoke, you will be able to see it very clearly, the path of the light. And apart from that, you can also do one more thing. Where is my lens? Oh, there it is. Fine. So as you do this, okay, so I'll just keep it there. Okay, I'll just hold it there a little. Fine, so that I have enough of. Okay, and now I have a lens here. Fine, can you see this lens? Now, if I pass the light through the lens, can you see the light actually bending around?
Yes,
yeah, can you see the light bending?
Yes.
With a prism, this acts even mighty beautiful. Okay, so if you leave the light to the center, it will go straight. But if you bring it to the outer periphery, you can see the light is bending. And not just this, you can actually do this experiment with prisms, with glass slab, with mirrors. You can actually show them how the light is actually moving, the path of the light. You don't have to make the child imagine. You don't have to make the child visualize it in his head. You can actually show it to them. Fine. The best way would be to actually make a big cardboard, use a optical bench inside it, so that you can have steady hand, everything, and use as much smoke as you can. The more smoke it is, the more dense it is, the better the visualization. Here it is not very good. I also could not visualize it very properly, but you will be actually able to see it. When you put the glass prism, trust me, the effect is amazing. The light that goes like this, it simply bends. I could not find the glass prism. I don't know where I've kept it. Fine, so I could not show it to you. But using the glass prism, using the what you call this thing, the mirrors, we teach them about angle of incidence is equal to angle of reflection. You can actually show them. In class 10 and 12 also, there's this experiment of prism and what you call this thing, the glass lab, in which you use pins to locate the lateral transformation and all those things happening. You can do it with the help of lasers. Another interesting thing that you can do is you can use 3 colored lasers, red, green, and blue. We know that refractive index depends on the wavelength of the light. Just use the smoke box, place the prism, use the 3 lasers, ink synchronization, fine, parallel में एक साथ चला के चलाइए. रेड सबसे दूर जाके गिरेगा, उससे पहले आपका ग्रीन गिरेगा और सबसे पहले ब्लू. That will easily show you and easily show everyone that though they have started going parallel, but blue, because it's got a shorter wavelength, it immediately kind of bends fast. Red with a higher wavelength will go on longer time, right? It will go move a longer direction. So please try it out yourself, and trust me, I've just given you a small demonstration here. You can just make it big and show it to everyone. Okay. Okay, Veena ma'am, now it's over to you again.
Okay, so we what is the learning outcome of this activity? What just now Shubham sir has shown? Rainbow color gives the best, the beautiful experience. No, I'm just asking for the learning outcome. Without the learning outcome, any activities, there's no point. Quickly, can you? Sir has already explained you. So lots many light travel in a straight line. Then the sir has used that lens. Then he has shown the diversion of that. Then what refraction? Yes, refraction can be. Prism can be used. Bending, angle,
refraction,
direction,
reflection, everything regarding light can be done.
So this is a one kind of an activity. As much as you explore, you will get lots many. Almost all the concepts of light can be explained with the box and smoke and one small laser light. You teach, yes, very nicely. Someone has told that is dispersion, reflection, normal.
Exactly.
What we talk about the normal of incident ray. And then this otherwise we all
reflected, refracted. In fact, this entire thing is working because of scattering of light. You can see the path of light because of scattering. You can start with that. You can see, you cannot see light. हम light नहीं देख सकते. Fine. Yes, focal length also. Everything. Absolutely everything you can do. In fact, you can do जो हम लोग ray diagrams बना के दिखाते हैं कि light ऐसे गया, U-turn किया, एक center में से निकला जहाँ you can actually do it using 2 lasers, a green and a red, or a red and a blue, whatever 2 colors. You need an optical bench, a big carton. एक नहीं मिलता, 2 को जोड़कर बनाइए. In fact, me and Veena ma'am, we actually made this thing. We made a big one. Fine, we put it in our school. We inserted a what you call this thing, an optical bench. Yeah, and we used a helium neon laser. We had a much more powerful laser there. Fine, and then we placed one light that went right through, the convex lens and bent. The other one we sent it through the optical center. जहां पर भी ये दोनों light precisely meet करते हैं, that is the point where the image will get created. You can actually show it. You don't need to put a lot of, what do you call it, cognitive load on the children. You can actually show them. बैठ के उनको सोचने की जरूरत नहीं, उनको दिखेगा.
So that's what I was coming again to the point. That is the example what we are talking about, this 21st century competency. That is creativity and innovation. What sir has just told you that in our field, being a teacher, how creatively and how innovatively we are doing. This is what the experiment with the box and to explain all the concepts of light. It's just an innovation in the field of teaching. What is done by him. So lots many things are existing. Only the thing is how we need to modify. That is called innovation. So critical thinking and problem solving, capacity of lifelong learning, that is a very important thing. Is this that? It is to be said there is lots many people in the world who are to be so-called degree holder, but they are not an educated person. So is that a lifelong learning, that it should be an aim and objective of every subject, not only the science, and the collaboration, communication, citizenship, and the character and computational thinking. So, sir, next, can we move on next?
Yeah, sure.
A simple question I'm going to ask, sir, this is all theoretical thing. To come to the point, that is banana activity I was talking about. The
sure.
thing is this, that when we are... Yeah.
I'm sorry.
just
one
activity. You do. Okay.
Just one more thing.
Yes.
See, now we are in a lockdown period, fine, and we are doing all kinds of online things. Now, most of us have access to a smartphone, fine. Now, you can use the smartphone to design variety of experiments, fine. Now, one experiment I'll show you, you can design the rest. This is an experiment in which you use the mobile's Hall sensor, fine. This is called a magnetometer sensor. You'll have to download an app called CPU Z. You'll find it on the Play Store, Fine. If you can do it right away, well and good. Otherwise, I'll just show you how to do it. Once you have downloaded CPU-Z, then what you have to do is that you open the app. On the top of it, there is this thing called sensors. Fine. Can you see this thing here? So there's a thing called sensors. Inside the sensors, there is a thing called magnetometer, right about here. This magnetometer, the value that it is showing right now, in the absence of any nearby magnet, is the magnetic field strength of Earth at this place. यहाँ पर ये थोड़ा सा अभी कितना दिखा रहा है? It is showing about 40 something. The magnetic field of Earth is ranging somewhere between 25 and 60 microtesla. Different places have different field strength. Fine. The average is approximately 40 microtesla. This is the magnetic field strength of Earth. And if you bring anything close to it, anything in terms of a metal, now I have this bottle, find this Milton bottle. And if I bring close to it, fine, and you will see there is a jump in the magnetic field strength. From 40, it has reached, from 44, it has reached about 51 right now. Similarly, if I bring the magnet that I showed you, this one, now I am taking a big risk with my mobile, fine. If I bring the magnet near it, okay, it's on this side. Can you see the value that has gone up? It's gone beyond 2000. What I have done is what I have told my students to do is I have given them a small worksheet. Fine. I'll just show you. There it is. These are the sensor readings. This is a simple, format that I have made for the children, in which I have told them to do the experiments as the 4 experiments that I've told them near Earth, for the Earth's magnetic field, influence of metals, near a magnet, near a solenoid, and all these things. And then I told them to do their own experiment. They can take it anywhere, to any kind of magnet, to any metal, iron, steel, aluminum, and so on and so forth, and record kitna value de raha hai ye magnetometer. It is a very awesome piece of experiment that you can show, or you can ask the children to do, in order to learn about magnets. And you don't need any piece of costly equipment. All you need is a smartphone. Every smartphone, almost every, I'll not say every, almost every smartphone has a Hall sensor. All you need is the app called CPU-Z. Fine. And you can design your own experiments. The app name is CPU-Z. Okay, you can design your own experiments. Another app is called Firefox. Okay, I'm sending it. I'm sending the name of the apps to everyone. The first one is called CPU-Z, and the second one is called Firefox. Okay, the second one is called Firefox. These 2 apps will help you design not only experiments for magnets, but for electricity, for light, for luminous intensity, for acceleration due to gravity. सीधा you पकड़ के drop कर दीजिए, z-axis का 0 हो जाना है immediately. You just bring it up and down, you just move it sideways, you can show them acceleration at work. Fine. Acceleration, everything in physics. Now, I'm a physics person, that's why I'm harping on it. Fine. Everything related to physics or general science, you can do with the help of these the smartphones. And CPU-Z is one, and the Firefox is the other one that you can do with. Fine. Okay, ma'am, I'm going over to you again. Where is the thing?
So coming back to again, that is
no, I was searching for that banana thing. I think I placed it in there.
Okay, so I was talking about that what will happen when you will come back when wait, when you will open when the schools will get open, and when we are going to talk about the why the schools were closed then because of the corona. What exactly is the corona? Corona is a virus. What exactly is a virus? And why it is coming to in our body? All those things. Actually, the guidelines are getting ready, and we need to prepare our children when they are coming to the school to tell them what exactly is this, to make them feel that is how dangerous is it, and what, so that automatically they will start taking the precautions and all those. So when we are coming to this point, how to explain the child what is the coronavirus, the virus which is not seen, and what exactly is a virus? If you talk about that, it is just a DNA material, and DNA material, when it takes your cell as a shelter and covering So then it becomes active in it. So when you talk about the DNA, it is a DNA material. When it enters in our body, it gets the shelter of a cell wall and then it starts surviving itself. So coronavirus. So how will you make the child see what exactly is a DNA? One thing. Second thing, when we talk about that, especially in the primary children, when they have a curiosity, when they are entering from the age of their, I should say from childhood to the adolescence, starts from the age of somewhere in 8 or 9 years and ended to the age of 26 years. So when they are entering into this phase, their normal question comes that is, ma'am, how come a baby comes in mother womb? And हम कैसे बने थे? How come we have made? So when we talk about at this level, we cannot make them explain. So a little bit diversion is required. That see why we resemble to our parents, why papaya tree gives papaya only, why the mango tree gives only mango. So why we resemble to the parents? Because of the DNA material. And when we talk about this one heredity, Divya, you are very right, but for a small child it is very difficult. So how can you show them what is a DNA material and how this DNA material is forming a virus, and this virus is entering into a body? So sir, it's a very simple experiment, you all are knowing, just it's a recap to show, but it for the child's life it's very important. I know that Divya, all those big terms, genes, heredity, and all those things, but for the level of the small children, those who are just about to enter the school and they don't know the dangerousness of this virus. So we need to show them DNA, and this is the expectation from Banana. Sir, it's you can show exactly to them. So rubbing alcohol, almost all of you must be having.
Sorry. I mistimed again. Yes, ma'am, I've stopped it now.
So, okay, so you have to show this. You can use the ingredient. All the other things will remain same. You can use onion. You can use your papaya. Papaya also gives a very good picture of this DNA. So you just show the little ones. This is called DNA, and this is how the body of a coronavirus is made from. And then we have to break the wall of this. And for that, what we require? We require either soap to wash our hands, and this is how the outer layer of the DNA will break. And then what will happen? Then this virus will, no more survival of the virus will be there. So this is how you need to make the children, and the little ones are coming inside. Sorry, just go.
Okay, in the meantime, after ma'am is over with this, I'll be telling you about this other thing that you'll be able to use to teach physics, chemistry, and biology, all of them. Fine. I'll be taking you to the world of simulators.
Okay,
yes, ma'am.
So
please continue.
you can move ahead, Shubham. You can go on a
Okay, fine.
simulator. And remember that we have only 10 minutes in our hands.
Okay, fine. I'll be done with this.
Okay.
Now see, all you require is the simulators here. Fine. Now simulators are programs, softwares that you can help you to create a virtual laboratory. Fine. I'll be showing you with the help of an electrical one. 4 things are required at your end. You need to go to fet.colorado.edu. Please note down this website that's given here. You go there, you'll find all simulators free of cost. You can download them. They're very small simulators. The FET experiments are also available on Play Store. Okay, you can get it, but it will cost you 65 rupees, a one-time price. Fine. After that, you'll require Java runtime environment, JRE 1.8 या above. ये oracle.com से आपको मिल जाएगा. फ्लैश प्लेयर की कभी कभी जरूरत पड़ती है, एंड HTML5 बेस्ड वेब ब्राउजर जो आजकल सभी मॉडर्न वेब ब्राउजर्स होते हैं. After that, I'll show you how exactly this thing works. Fine. I may need to close this presentation for a moment, and rather I'll take you here. Where is it? There it is. Okay, and I'll open this with Java runtime, and you have the simulator here. And now let me just share it with you again. Can you see the blue thing here? The blue screen? This is a simulator screen. Fine. Now I'll just show you the simplest of all things. That is a basic circuit कैसे बनाया जाता है. You need wire, you need battery, you need a light bulb, and you need a switch. That's all you require. Fine. Connect the wire to one end of this bulb. Fine. It's simple drag and drop. You take the wire here, you connect it there. Fine. You can just turn it a little for your own ease, and now you just connect these two. Fine. So I've connected them. You just switch it on and see the bulb is glowing. ये एक सबसे simple experiment when we teach the children, especially the junior ones, fine, about electrical circuits, rather than actually give them a bulb or a battery, fine, which is obviously the best thing to do, but at this point of time during lockdown you cannot really do it. Fine. This kind of an online simulator seriously helps. It is easily downloadable. This software which is running here is barely 3.2 MB. Fine. आजकल के MP3 songs इससे ज़्यादा भारी होते हैं. So it's very simple. You just download it and you can show it to the kids. And you can do absolutely any kind of experiment. Resistance in series, resistance in parallel, potentiometer, everything. Electricity, AC and DC से related, induction, resistor and capacitor से related, हर experiment जो मुमकिन है वो आप इससे कर सकते हैं. I will recommend you that please go to the actual website, which is fed.colorado.edu. Fine. Go to the website, and you will be able to see the, just a minute, let me just share the screen with you. Fine, there we are. So you please go to the website and you will find simulators from physics, chemistry, as well as biology, mathematics, geography, space sciences, absolutely everything there. There are hundreds of simulators. Every one of them is free of cost for you to work on. Okay, you please take help of these things, and you can find a lot of materials, a lot of simulations that will help you to teach, and you can as well hand it over to the kids, tell them how to download it. Fine, yeah, I have already written it down. It's fed.colorado.edu. It's already also given on the board, as well as a few things that will be necessary for you to run these simulations. Fine, they require a background support of Java runtime environment. You can download it from oracle.com, and you would have to download a Flash player also, Adobe Flash Player, free to download. You can download it, and HTML5 based web browser, which are all modern web browsers. Fine, Firefox is my favorite. You can take up any other. Fine. So once you have downloaded these things, just play around with them, teach the students using the simulators, give them the simulators, ask them to do all kinds of things. You can even make activities, you can make assignments the way I do. I tell them parameters and they have to make the design and send it back to me. Fine. So
Shubham sir, we are having in the mathematics also.
Yes, in mathematics, fractions, one of the most difficult things to teach. Fractions, area, volume, everything is done in these simulators. There are simulators for them also. As I stated, physics, chemistry, mathematics, biology, geography, space science, universe, every kind of simulator you'll find.
Okay, sir. We are running short of time because other things also are lined up. I just wanted to share with you. Generally, we are having a concept of that experiential learning, which is to be so-called hands-on. If I ask you in a one line, what do you mean by experiential learning? It is to be said that, ma'am, it's hands-on. It's not exactly is a hand-on. It is a combination of all things. So just as a quick diagram, you can take a pic of this. So what exactly is this? You have to go through that accommodating, diverging, assimilating, and converging. And then Shubham sir, may I see the last slide that is about the I was having a diagram of a magnetic effect.
Yes, I'm going there.
Just quickly go. Yes, this is it. So this is one just simple an example that fun with magnets in class 6 the chapter, and how you can do with the experiential learning. So you concentrate that is this is an experience, then reflective observation, then conceptualization, then active experimentation, and then how you just take a quick this one a pic you can take and then see this the simple thing fun with magnets one activity this a compiling way that what we and if we talk about the Bloom's taxonomy and other things, so how this is a combination of this. So I today just I wanted to tell you that is experiential learning is not just in combination of in hand, it's just as simple as hands-on, it's beyond that. So that's all about today. If you have any doubt, anything, quickly write in the chat box and ask from us.
I'm also mentioning the name of the super magnet that I use.
Yeah, they must have asked.
It is called neodymium ferrite magnet. It is available online only. Fine, so you'll have to purchase it from online. I have never really come across any merchant, any vendor who is selling it offline. Amazon and eBay dono pe mil jayega.
So quickly you can ask anything if you have any doubt. Hurry up fast, we are running short of time. Ma'am, over to you, Shubha ma'am. Yes.
Yeah, thank you so much, Veena ma'am and Shubham sir. You know, I was just amazed at the experiments, and I'm sure our participants had the same feeling. And I seriously wish if I had you both as my science teachers, I guess science would have been my favorite subject. So teachers, I'm going to post a link over here on the chat box. Please do give feedback as to what further science sessions you would want us to organize in any other comments. Apart from that, the feedback link also would be sent to your schools and principals. Thank you so much once again, Veena ma'am and Shubham sir, for this amazing science session. And I seriously wish we had more time for it. Looks like we ran short of time. Okay. Right. All right, participants, I request all of you to unmute yourselves and give a huge round of applause to both our facilitators.
Thank you.
Do that.
Thank you. Thanks a lot.
And give a round of applause. Shubham sir and Veena ma'am.
Thank you.
Thank you.
So much.
Thanks a lot.
I'm going to end this meeting as we have another webinar lined up. So goodbye, all of you.
Thank you.
Goodbye,
Bye-bye.
everyone. Thank you, everyone.
Thank
Bye.
you. Thank you. Thank you.